Do other scientists believe we may be heading for an ice age?
Yes. In 2006, for example, chief researcher Kababulo Abdusamatov at the Russian Academy of Sciences said that he believed worldwide average temperatures would slowly decrease from 2012 to 2015. And then in the middle of the century there would be a much more precipitous drop in temperatures that would last for 60 years.
Does it have to be raining for there to be lightning?
There needs to be a storm for there to be lightning. But it does not have to be raining in the same location for lightning to occur. Lightning strokes have been observed as far away as 10 miles, 16 kilometers, from where rain was actually falling. And lightning strokes may happen as much as 10 minutes after all rain has stopped.
What is a sunspot?
Sunspots, when viewed by visible light, appear as dark blemishes on the sun. Most sunspots have two physical components, the umbra, which is a smaller, dark, featureless core, and the penumbra, which is a large, lighter surrounding region. Within the penumbra are delicate-looking filaments that extend outward like spokes on a bicycle wheel. Sunspots vary in size and tend to be clustered in groups. Many of them far exceed the size of our planet and could easily swallow Earth whole. Sunspots are the sites of incredibly powerful, magnetically driven phenomena. Even though they look calm and quiet in visible light. Pictures of sunspots taken in ultraviolet light and in X-rays clearly show the tremendous energy they produce and release, as well as the powerful magnetic fields that permeate and surround them.
How does the hydrologic cycle work?
The movement of water from the atmosphere to the land, rivers, oceans, and plants and then back into the atmosphere is known as the hydrologic cycle. We can pick an arbitrary point in the cycle to begin our examination. Water in the atmosphere forms clouds or fog and falls, precipitates, to the ground. Water then flows into the ground to nourish plants, or into streams that lead to rivers and then to oceans. Or it can flow into the groundwater, underground sources of water. Over time, water sitting in puddles, rivers, lakes, and oceans is evaporated into the atmosphere. Water in plants is transpired into the atmosphere, too. The process of water moving into the atmosphere is collectively known as evapotranspiration.
Will there be an ice age in the future?
Yes, eventually the Earth will again cool and ice will cover land at higher latitudes and elevations. When this might happen, no one is really sure.
What are the different scales of atmospheric motion?
Meteorologists divide weather patterns and motions based on actions that are occurring at various scales of size. Just as economists have macroeconomics, how the economy functions on a regional, national, or international level, and microeconomics, financial concepts applied to a single household or business. Meteorologists find it convenient to divide weather phenomena this way, too. Below is an explanation of the divisions. The macro scale, or synoptic scale, refers to weather processes affecting large areas, such as pressure systems, fronts, and the jet stream. The microscale concerns highly localized events, such as a tornado, a fog bank, or a small rain shower that affects an area of only a few hundred square feet or meters. The mesoscale deals with weather events somewhere between the micro and macro levels, usually ranging over several miles to 100 miles or so. Thunderstorms, cloud systems, and breeze fronts are some examples of weather falling into this category. The mesoscale is sometimes divided even further into one, mesogamma, covering about 1 to 12 miles 2 to 20 kilometers, 2, mesobeta, 25 to 125 miles 20 to 200 kilometers. And 3, meso-alpha, 125 to 1250 miles 200 to 2000 kilometers.
How hot is lightning?
The temperature of the air around a bolt of lightning is about 54,000 degrees Fahrenheit. 30,000 degrees Celsius, which is 6 times hotter than the surface of the sun. In cloud-to-ground lightning, energy seeks the shortest route to Earth, which could be through a person's shoulder, down the side of the body, through the leg, and into the ground. As long as the lightning does not pass across the heart or spinal column, the victim can usually survive.
What happened at 3 Mile Island?
Three Mile Island, Pennsylvania, was the site of the United States' worst nuclear accident. Luckily, no radiation was released into the environment and no one was killed. In March 1979, the nuclear reactor at the 3 Mile Island plant overheated, breaking the radioactive rods. Pennsylvania's governor recommended a voluntary evacuation of pregnant women and preschool children who lived within 5 miles, 8 kilometers, of the plant. It was the unexpected self-evacuation of residents in the area that created major problems. The Evacuations yielded surprising information about the lack of preparedness of communities for such an event, and have led to increased planning and preparedness for nuclear accidents and evacuations.
Is the Earth's rotation slowing down?
Yes. About 400 million years ago, there were 400 days a year, versus the present day 365. Eventually, if the sun doesn't die first, the Earth will stop rotating completely.
What major energy source is considered to be the cleanest?
Natural gas is regarded as the cleanest burning fossil fuel, producing less pollution than oil or coal.
Why was tornado forecasting once banned in the United States?
Concerns that warning people about possible tornado formation would panic. Residents led the Weather Bureau to ban such forecasting off and on in the 1940s. As meteorology improved and tornadoes became somewhat less terrifying in their ability to appear suddenly, the ban was lifted in 1950.
What are some of the worst floods in history caused by inclement weather?
Not all lethal floods in recorded history have been caused by bad weather. For example, seawall failures in the Netherlands have, on several occasions, caused tragic floods that killed thousands. The table below, though, lists some of the worst weather-related floods in history.
What happened in the 1940s and 1950s that gave hope to the science of numerical weather prediction?
Hungarian-American mathematician John von Neumann, 1903 to 1957, devised a forerunner of the modern computer that could make the rapid calculations needed to predict the weather using the numerical forecasting method. Next, Princeton University meteorologist Jules Charny, 1917 to 1981. Having studied Richardson's earlier failure, wrote revised formulas in 1946 that could be used for weather prediction with the help of von Neumann's computer. With this background foundation in place, in 1950 the first successful weather forecast using the numerical method was completed in April, 1950, by the ENIAC computer at Maryland's Aberdeen Proving Ground. An ongoing weather forecast service was then begun in 1955, using an IBM computer funded by the National Weather Service, and the U.S. Navy and Air Force.
Is a halo around the sun or moon a sign of rain or snow approaching?
The presence of a ring around the sun or, more commonly, the moon in the night sky betrays very high ice crystals composing cirrostratus clouds. The brighter the ring, the greater the odds of precipitation and the sooner it may be expected. Rain or snow will not always fall, but 2 times out of 3. Precipitation will start to fall within 12 to 18 hours. These cirriform clouds are a forerunner of an approaching warm front and an associated low-pressure system.
On where does the word gas come from?
The person who is credited with coming up with the word gas is Flemish physician Jan Baptiste van Helmont, 1577 to 1644. His experiments with gas and volume taught him that gases always take up all the space within a container, they do not leave a vacuum. Thus, he surmised that substances in a gaseous state exist in a chaotic form. The Flemish pronunciation for chaos sounds like gas, and thus the word was born. Earth, this is accomplished by plants and algae that conduct photosynthesis. Removing carbon dioxide from the atmosphere and adding oxygen into it. It was during the Carboniferous period about 300 million years ago that plant growth dramatically changed the atmosphere, increasing the amount of oxygen to 35%. Today, the oxygen content is not quite as rich, 21%.
What U.S. cities receive the most sunlight annually?
Yuma, Arizona, is regarded as the sunniest city in the United States. With about 4,000 hours of sunlight every year. Below are some other sunny cities for those who are averse to rainfall. Because what constitutes a sunny day is debatable, the figures are estimates of the percentage of hours of annual sunshine, or what meteorologists call the mean percentage of possible sunshine.
What was the tempest prognosticator?
In 1851 Dr. George Merriweather displayed his tempest prognosticator at London's Great Exhibition. Remarkably, this leech barometer used the infamous blood-sucking worms to predict changes in air pressure and, thus, forecast inclement weather. Leeches require moisture to stay alive, and so they usually remain underwater unless it is rainy and wet outside their river and pond homes. It is believed that leeches possess a kind of natural barometer that tells them when a low pressure system is bringing wet weather and they can venture outside to seek victims to feed upon. Merriweather's contraption worked by placing one leech in each of a series of 12 bottles filled with about 1.5 inches of water. The bottles were arranged in a circle, and at the top of each bottle was a wire connected to a bell. When the air pressure was high, the leeches would remain in the water. When the air pressure began to fall, however, the leeches would become more active and climb up the bottles, eventually ringing the bells.
What is the National Center for Atmospheric Research, NCAR?
Established by the National Academy of Sciences in 1956, the NCAR is based in Boulder, Colorado, and is staffed by, mostly, university scientists who use such tools as radar, airplanes, and supercomputers to help the scientific community better understand the many processes that affect weather. The goal is to increase cooperation between universities and draw on their combined resources in order to accomplish what a single university could not do on its own.
Who wrote the Meteorologica?
The Greek philosopher Aristotle, 384 to 322 BCE, released his Meteorologica around 340 BCE. It was this work that gave us the term meteorology. In Aristotle's time, the word meteor referred not just to extraterrestrial rocks entering the atmosphere but rather to anything up in the sky, including clouds, rain, snow, etc. Meteorologica is the first comprehensive text written on the subject, at least in the Western world. Many of the theories expressed in Aristotle's work, however, are based on mythology and other misplaced notions of what causes weather. For instance, the philosopher believed that hurricanes resulted from a moral conflict between evil and good winds.
How were the Van Allen belts discovered?
In 1958 the United States launched its first satellite, Explorer 1, into orbit. Among the scientific instruments aboard Explorer 1 was a radiation detector designed by James Van Allen. 1914 to 2006, a professor of physics at the University of Iowa. It was this detector that first discovered the two belt-shaped regions of the magnetosphere filled with highly charged particles. These regions were subsequently named the Van Allen belts.
What is Earth's magnetic field?
Electromagnetic force permeates our planet. In essence, Earth itself acts like a giant spherical magnet. This is caused primarily by the motion of electrical currents within Earth, probably through the liquid metallic part of Earth's core. Combined with Earth's rotation, the core acts like an electric dynamo or generator, creating a magnetic field. Earth's magnetic field extends thousands of miles outward into space. Magnetic field lines, carrying and projecting electromagnetic force. Anchor at Earth's magnetic poles, north and south, and bulge outward, usually in large loops. Occasionally, they stream outward into space. The magnetic north and magnetic south poles of Earth's magnetic field are very close to the geographical north and south poles, which mark the axis of Earth's rotation. Be careful. By the way, there are two ways to define Earth's magnetic poles. The magnetic North Pole is on an island in Canada, but the geomagnetic North Pole is actually on Greenland. And the geographic North Pole is on an ice shelf floating on the ocean, hundreds of miles from any land.
Are there any other tornado strength scales in use?
Yes. In Great Britain, meteorologists use the TORO, the Tornado and Storm Research Organization scale, which is divided into T0 through T10 measurements of strength. A T0 tornado has winds beginning at 40 miles, 64 kilometers, per hour. An AT10 is a super tornado with wind speeds of 270 to 299 miles, 435 to 480 kilometers, per hour.
Who first hypothesized that the amount of carbon dioxide in the atmosphere had something to do with climate change?
Swedish chemist Svante Arrhenius, 1859 to 1927. Was the first to propose that the atmosphere would hold more heat as concentrations of carbon dioxide increased.
Is our climate changing?
Human lifespans, when compared to geologic time, are extremely brief. And so it is hard for us to imagine our planet's climate being much different than it is today. The fact is that over thousands and hundreds of thousands of years the Earth's climate has experienced wide fluctuations, ranging from the snowball Earth of about 635 million years ago to the extremely warm conditions, 18 degrees Fahrenheit, or about 8 degrees Celsius warmer on average, than today, of a 100 million years ago when dinosaurs were flourishing. Over the millennia, there have been many periods of hot and cold. In the past, these have been caused by a variety of factors, ranging from volcanic activity to plate tectonics to the possibility of an asteroid crashing into the planet. Today, scientists fear we are undergoing a new and dramatic climatic change with one important difference: they believe humans are causing it.
What should you do if you are stranded in your car during a blizzard?
If you are far from any buildings or people who might help, rather than getting out of your car and wandering off, possibly getting lost or freezing to death, it is always a better idea to remain in your vehicle. Hopefully, you will have a charged cell phone handy, but if not, it is still better to remain in the car. After checking to make sure that the car's exhaust pipe is not blocked by any snow or ice. Being wary of carbon monoxide poisoning, keep the car running for as long as possible to stay warm. Also, turn on your hazard lights, which may attract help, such as a police officer, while also warning snow plows not to come too close. During the winter months, it is a good idea to keep blankets, food, a spare tire, and a first aid kit in your car. Never drink alcohol to try and stay warm, but a thermos containing a hot beverage or soup would prove handy.
What were the major glacial ice ages over time?
Evidence from the geologic record shows that ice ages have occurred relatively few times in Earth's history, with the first known large-scale ice age taking place approximately 2.3 billion years ago. In the last about 670 million years, ice ages have occurred less than 1% of the time. Geologists believe there have been 5 major ice ages over geologic time. The following lists the occurrences: 1.7 to 2.3 billion years ago, Huronian era, Precambrian. 850 million years ago, Cryogenian period, 670 million years ago, Proterozoic era, Precambrian. 420 million years ago, Paleozoic era, between the Ordovician and Silurian periods. 290 million years ago, Paleozoic era, between late Carboniferous and early Permian periods, 1 million years ago, Cenozoic era, Quaternary period, Pleistocene epoch.
Why are radio transmissions weaker at night than during the day?
At night, of course, much less light is entering the atmosphere, which means that less ionization is occurring and fewer electrons are available for radio waves to bounce off of. The result is that radio transmissions are weaker.
Do other planets in our solar system experience weather?
Many planets and even moons in our solar system have atmospheres and, therefore, weather. The gas giants Jupiter, Saturn, Uranus, and Neptune all have very thick atmospheres which include storms and even lightning. Lightning has been observed on Jupiter, Saturn, Io, and Titan, and is speculated to exist on Venus. Jupiter, of course, is famous for the huge swirling Great Red Spot, which is a windstorm 8,500 miles, 14,000 kilometers, wide and 16,000 miles, 26,000 kilometers. long that astronomers estimate has been ongoing for at least 400 years. Saturn, too, has a thick atmosphere topped by crystallized ammonia clouds. It also has a great white spot. But this storm lasts for about a month and then fades, recurring at intervals. Uranus has a distinctive, blue-green atmosphere made mostly of hydrogen, 83%, and helium, 15%. Neptune also has a blue color, which is why it is named after the Roman god of the sea, with a hydrogen-helium-methane atmosphere. Below this upper atmosphere, astronomers believe Neptune has a lower atmosphere made of ammonia, crystallized methane, and ionized water. Even deeper may be a layer of hydrogen sulfide. The winds on all of these planets are believed to be very powerful. Neptune, for instance, has winds reaching 700 miles, 1,100 kilometers, per hour. The planet has a great dark spot, that is an ongoing storm about the size of Earth's moon. And a smaller, white storm that has the whimsical name of Scooter. Not counting Earth, the inner planets Mars, Venus, and Mercury all have atmospheres. The atmosphere on Mars is very thin, and it has an air pressure about 1% that of Earth's. Theories abound as to why Mars lost its atmosphere, ranging from giant asteroids smashing into the planet and ripping away its air, to the lack of plate tectonics providing sufficient heat, to the idea that the planet somehow lost its magnetosphere. Without much atmosphere, Mars does not have much weather. Mercury, similarly, has virtually no atmosphere and is essentially a big rock in space. Venus is far more interesting than either Mars or Mercury, in terms of atmosphere. It is a planet with an atmosphere too rich in carbon dioxide, and consequently it experiences a runaway greenhouse effect that heats the surface to 900 degrees Fahrenheit. 500 degrees Celsius, which is hot enough to melt metals like lead, tin, and zinc. Poor Pluto, which has been downgraded in status from planet to planetoid, has a thin atmosphere containing nitrogen, methane, and carbon monoxide. Several moons in our solar system also have atmospheres. Of these, Saturn's Titan is perhaps the most interesting. Its dense atmosphere, 50% denser than Earth's, contains 98.4% nitrogen and 1.6% methane. Astronomers believe that Titan has lakes and seas composed of liquid methane and nitrogen, and that it experiences rain showers made of methane. A smoggy, orange haze made of hydrocarbons envelops the atmosphere. Some other moons have thin atmospheres, such as Neptune's Triton, and Ganymede, which is another moon circling Jupiter, is believed to have a water ocean beneath a layer of ice.
What is a mirage?
As light passes from warm to cool air, or vice versa, light is refracted, causing images to appear in places distant from their actual location. Mirages are frequently seen on hot days and on surfaces such as road pavement. sand, or concrete, where the surfaces are very hot. In such cases, light rays from the distant horizon appear wavy and close up, making it appear as if water is nearby.
What is evapotranspiration?
Evapotranspiration is the combination of water vapor being evaporated from the surface of the earth, such as from lakes, rivers, or puddles, into the atmosphere. And transpiration, which is the movement of water from plants to the air.
Why is infrared light from the sun important?
Infrared light from the sun provides about 50% of the solar energy that reaches Earth in the form of heat. Without it, our planet would be a much colder place. The rest of the heat energy comes from light in the visible spectrum range that, after it is absorbed, radiates back into the atmosphere in the form of heat.
Is the relative humidity always 100% during times when it is raining or snowing?
While the formation of rain and snow within a cloud requires humidity to reach a saturation point, by the time the precipitation reaches lower elevations and the ground, the rain, hail, or snow can exist within air that has a lower humidity.
Does all carbon dioxide released as pollution remain in the atmosphere?
No, not at all. A lot of it is reabsorbed by plants, as well as the oceans, where it turns into carbonic acid. Forests and oceans can only do so much, however. Especially when people are cutting down forests all over the planet. It only takes 1 acre of forest to absorb about 13 tons of gas and particle pollutants annually. What is not absorbed remains in the atmosphere. And people are producing so much CO2 and other pollutants that there is a net gain in global warming gases.
Can meteorologists predict tornadoes?
It is difficult to nearly impossible to predict where and whether or not a tornado will strike. All forecasters can do is warn people when conditions are right for tornadoes to form. Or, if one is sighted, to tell people to take shelter. Meteorologists look for tornadic thunderstorms that have strong indications of wind shear, lift, moisture, and instability. No one type of weather pattern leads to tornado formation, which greatly complicates forecasting efforts. To aid in their predictions, meteorologists use all sorts of technology, including weather balloons, Doppler radar, satellites, data from weather stations, lightning strike plots, and computer modeling.
What happens to domesticated animals during blizzards?
Farm and range animals certainly suffer as much as people during blizzards. For example, in the blizzard of 1886 that hit the Central Plains states of America, about 80% of livestock perished in the worst affected areas of Texas, Oklahoma, Nebraska, and Kansas. In 1966, 100,000 head of livestock died in Nebraska, Minnesota, North Dakota, and South Dakota when a blizzard dumped 30 feet, 9 meters, of snow, drifts of up to 30 feet. Over 9 meters, accumulated, and winds gusted up to 100 miles, 160 kilometers, per hour.
What does a 40% chance of rain really mean?
When the morning weather report speaks of a 40% chance of rain, it means that throughout the area, usually the metropolitan area, there is a 4 in 10 chance that at least 0.001 of an inch of rain, 0.0025 centimeters, will fall on any given point in the area.
How wide is a lightning bolt?
Because of the intense glow of light that is emitted from lightning bolts, they may appear much wider than they actually are. The speed of lightning can vary from 100 to 1000 miles. 160 to 1600 kilometers per second for the downward leader track. The return stroke is 87,000 miles. 140,000 kilometers per second, almost the speed of light.
What are the two forms of cloud-to-ground lightning?
Cloud to ground, CG, strokes of lightning come in negative and positive forms. Negative CGS, which make up about 95% of all such lightning strokes, occur when the ground becomes positively charged. A positive CG does the opposite, and the ground becomes negatively charged. Positive CGS tend to have more power and longer strike time, thus, they are more likely to cause damage and are blamed for starting more forest fires.
Are some people allergic to the cold?
Research indicates that some people are, indeed, allergic to cold temperatures and may develop a rash as a result. Antihistamines can relieve symptoms, just as they do with exposure to other allergens.
Where do hay boobs occur?
Derived from the Arabic word hab, meaning to blow, a habub is a violent dust storm. Habubs are common in the Sahara Desert, as well as in the deserts of Australia, Asia, and North America.
What's the difference between dew point, humidity, and relative humidity?
While humidity and dew point are both measures of the amount of water contained in the air, humidity is measured as a percentage of water/air, while dew point is indicated by temperature. The dew point indicates the temperature at which the air would become 100% saturated. The bigger the difference between the dew point and the current temperature, the less humid the air is. It is therefore the same type of measurement as relative humidity, except that relative humidity is expressed as a percentage and dew point is expressed using temperatures.
What is the lowest temperature possible?
According to physics, the lowest temperature possible is 0 degrees Kelvin. Minus 459.67 degrees Fahrenheit or minus 273.15 degrees Celsius, which is also known as absolute zero. This is the temperature at which molecular activity stops, and it is not possible for any more heat energy to be lost. Such an extreme, of course, does not exist naturally on Earth, except in some university laboratories. The lowest air temperatures can go on the planet is about minus 130 degrees Fahrenheit, minus 90 degrees Celsius. An unverified reading of minus 132 degrees Fahrenheit, minus 91 degrees Celsius was reported at Vostok, Antarctica, in 1997.
What are you seeing when you see your breath?
It can be fun for kids to breathe out on a cold day and pretend that they are perhaps dragons. But it is obviously not smoke coming out of their mouths, it is water vapor. What is happening is that the moisture in one's breath, humidity, is turning to fog as it leaves the warm confines of the mouth and hits the chilly air. While one or two people breathing out on cold days will not affect the weather, it has been observed that large herds of animals huddling together on a winter's day can actually produce a small fog bank.
What was the most important weather book to follow? Meteorologica.
Aristotle's student Theophrastus of Ersus, c. 372 to 287 BCE, continued his mentor's study of weather with his On Weather Signs, a book that became the last word on weather. It was consulted all the way through about the 12th century, when it was still used by scholars of the Byzantine Empire. As a predictor of weather, the book strove to describe how to tell when rain, wind, and storms were coming. Theophrastus's version of meteorology, though, was still a mix of well-reasoned observation and superstition.
What is wind?
Wind, simply put, is the movement of air in the atmosphere. Wind movement is caused by the fact that air will move from high-pressure areas to low-pressure areas.
Did people in ancient times really believe lightning came from the gods?
The power of lightning has impressed cultures for millennia. People, indeed, felt that it was a divine event and that lightning held mystical powers. The Romans and Greeks viewed them as spears, which were forged by the god Hephaestus. Vulcan, in Roman mythology, and then wielded by Zeus, or Jupiter, in Rome. Norse mythology gives the chief god, Odin, a spear made of lightning that he names Gungnir. And the Hindus also gave their god of war, and weather, Indra, a thunderbolt weapon. Sometimes, lightning was used as a symbol in these cultures. The Mayans used a triple lightning symbol to represent Hurricane, a god of creation who controlled the powers of wind, fire, and storms. There was also a belief, interestingly held by the Mayans, the Romans, and in Hindi culture, that mushrooms would grow in places where lightning struck.
What are supercooled droplets?
A supercooled droplet is a cloud droplet that remains in its liquid form at temperatures far below the freezing point, as low as -40 degrees Fahrenheit. Clouds formed of supercooled droplets pose potential hazards to aircraft that fly through them, because they can cause ice to form on wings and propellers. When low to the ground in the form of fog, supercooled droplets can also create hazardous road conditions by causing ice to form on streets and highways. On the other hand, supercooled droplets can also result in great beauty when they paint the landscape in a sparkling layer of ice that makes trees and other plants shine.
Where are the neutrinos coming from?
The vast majority of neutrinos striking our planet come from the Sun. The nuclear reactions at the core of the Sun create huge numbers of neutrinos. And unlike the light that is produced, which takes thousands of years to flow their way out of the Sun's interior, the neutrinos come out of the Sun in less than 3 seconds, reaching Earth in just 8 minutes.
What are the national ambient air quality standards?
Part of the Clean Air Act, the National Ambient Air Quality Standards, NAQS. are set values that are considered the maximum limits before air becomes too unhealthy to breathe safely. Industries that produce pollutants must adhere to these standards or else face fines and other penalties from the federal government. The standards are listed below.
What is a Bermuda high?
Bermuda high is the term given to an anticyclonic system in the western Atlantic that brings warm, humid air to the eastern seaboard of the United States.
What is a pulse Doppler radar?
Pulse Doppler radars, or simply pulse radars, are designed to better track the velocity of clouds, winds, and precipitation. They use radar in short, strong bursts with long intervals in between. To get accurate measurements, several pulse radars must be used in conjunction.
How many times does lightning strike the Earth each year?
About 20 million bolts of lightning are generated in the atmosphere every year. And during any particular second, about 100 to 125 lightning strokes are occurring on our planet. Thunderstorms are very common in the Earth's atmosphere, with about 1,500 to 2,000 such storms being active at any given time. For astronauts circling the Earth's night side, this makes for an exciting view, as numerous white flashes are easily viewed from a space shuttle or from the International Space Station.
How much land disappears when the sea level rises?
Scientists believe that as the sea water rises by 0.04 inches, 1 millimeter, the shoreline disappears by 4.9 feet, 1.5 meters. This means that if the sea level rises by 3.28 feet, 1 meter, the shorelines will extend another 1 mile, 1.6 kilometers, inland.
What is a photochemical grid model?
A photochemical grid model is a computer model used by meteorologists and environmental scientists to simulate what might happen during air pollution episodes under various weather conditions. A grid system is employed in which the area of study, for instance, a city, is cut up into thousands of cells, each usually a couple miles or kilometers wide and long. The cells also have a third dimension, height, varying in depth according to the altitude that scientists wish to study. These models simulate vertical and horizontal air movements, increases in various gases and particles from sources ranging from buildings and cars to plants and animals, and chemical reactions occurring in the atmosphere, they are very useful in predicting effects on ozone levels. A photochemical grid model is thus not the same as a meteorological model. But it does use this meteorological tool to study how pollution increases, dissipates, and affects certain areas. Photochemical grid models can be used to simulate how making different decisions affecting pollutant outputs would affect air quality. For example, if city officials decided to limit commuter traffic into the downtown area by 10%, they could simulate how levels of carbon monoxide would be reduced.
Could a sudden ice age like the one in the 2004 movie The Day After Tomorrow actually result from global warming?
No. That's Hollywood. In the movie, a scientist predicts, correctly for the plot of the film, which provides a lot of opportunities for special effects, that all the fresh water melting into the oceans will cause the Gulf Stream to dissipate, and that this will lead to the sudden onset of a new ice age. New York City freezes over in a day, and bizarre storm cells cause people to turn into popsicles in seconds. Ridiculous, say experts, though they admit that ice caps melting will indeed cause many adverse effects, such as rising oceans and changes in weather patterns. That said, it is interesting to note that ice ages can occur fairly quickly. Geologists and glaciologists estimate that some ice ages made significant advances through North America in spans ranging from a few decades to as little as 3 years. I heard that some glaciers in Alaska are growing, not shrinking. Is this true? It's true that many Alaskan glaciers, including, most notably, the Hubbard Glacier, have been advancing in recent years. The reasons for this are complex and may have nothing to do with whether or not climate change is occurring. To simplify what is the rather complicated science of glaciology, there are different types of glaciers. Some glaciers rest in valleys and tend to be more sensitive to changing temperatures. Others, including Hubbard, are known as calving glaciers. They terminate at an ocean and parts of them break away in a stunning spectacle known as calving. The 5 large glaciers in Alaska that are growing, including Hubbard, all have several commonalities. 1. They have previously experienced long periods of retreat only recently reversed, in the past century or so. 2. They all calve on shallow moraine shoals. 3. They all lay at the heads of long fjords. 4. They have positive mass balances that, by sheer force of weight, cause them to expand as gravity pushes down on them. And 5. They have small ablation areas, that is, small surface areas where melting and sublimation occur. Glaciologists note that glaciers with these qualities are not strongly influenced by even long-term temperature changes.
How much does air pollution damage crops in the United States?
It is estimated that the United States loses millions of dollars in crops every year because of air pollution. In the East, crop reductions cost about $3 billion in losses annually. And farmland near such cities as Los Angeles and Chicago is far less productive than land far from such cities.
What are the stages of a thunderstorm?
Thunderstorms have three stages: cumulus, mature, and dissipation. In the cumulus stage, warm, humid air near the ground is pushed upwards by strong thermals, or by the collision of air masses coming in from several directions at once. As this moist air rises, it cools and the heat that is released enters the surrounding air, causing convection that, in turn, causes more air to rise. A loop that feeds off itself causes a rapid increase in cloud formation. Temperature differences between lower and higher altitude, and rainfall. The storm reaches its second stage, the mature stage. When air has reached its cap and is not rising any farther. At this point, cumulonimbus clouds become cumulonimbus incus, thunderheads, with water droplets freezing at the top, thawing into rain as they descend. As the mixture of water, ice, and wind becomes more turbulent, an electrical charge builds up, aligning the ice crystals within the clouds until a bolt of lightning is discharged. This happens repeatedly until the storm weakens in the dissipation stage.
What are cooling degree days and heating degree days, and what do they have to do with air conditioning?
Utility companies in the United States use the term cooling degree days to refer to the number of days when it is likely that air conditioners will be turned on, and heating degree days to determine when furnaces are likely to run. Because it would be impractical to visit every home and business to see whether the air conditioner or furnace was running. Utility companies assume that customers are most comfortable when the temperature is 65 degrees Fahrenheit, 18.3 degrees Celsius, and that they will run their air systems accordingly. A degree day is not actually a 24-hour period. Rather, it is a measurement of the difference between the optimum of 65 degrees Fahrenheit. Fahrenheit is used as the standard because it is a US system, and the mean, average, temperature of a particular day. So, for example, if the mean temperature in Dallas, Texas, on a warm July day is 85 degrees Fahrenheit, the utility companies will count that as 20 cooling degree days. 85 degrees Fahrenheit, 65 degrees Fahrenheit equals 20 cooling days. The states with the most annual cooling days on average are Florida, Texas, Arizona, California, and other southern states that, on average, rack up about 4,000 cooling days annually. Heating degree days use the same concept to calculate furnace use. As one might imagine, northern states log more heating degree days than southern states.
What is one strange warning sign that lightning may be about to strike?
As the static charge begins to build as a precursor to a lightning stroke, people's hair may stand on end and you can feel the static charge in the air. It has also been known to happen that a plastic raincoat will begin to rise into the air, or that a cast fishing line will bizarrely remain suspended in air. Any of these signs are a warning to seek immediate shelter.
What is the low-level jet stream?
Seen in the central United States, low-level jet streams are air flows coming in from the Gulf of Mexico into the Central Plains. But they also occur as streams flowing from the Indian Ocean into Africa. Low-level jet streams occur at altitudes of only a couple thousand feet and can bring in moisture and warm air that creates severe thunderstorms and tornadoes. In the Central Plains, though, they only occur at night.
What are the different types of lightning?
Below are descriptions of the various forms that lightning can take. 1. Normal lightning, also called streaked or forked lightning, travels from a cloud to ground, b. cloud to air, c. cloud to cloud, or d. in cloud. 2. Sheet lightning, a shapeless flash of lightning that covers a broad area. 3. Ribbon lightning, normal lightning blown sideways by the wind, in a way that makes it appear like parallel, successive strokes. 4. Bead or chain lightning, lightning broken up into evenly spaced segments or beads. 5. Heat lightning, lightning seen along the horizon during hot weather that is a reflection of lightning that occurred beyond the horizon in a distant thunderstorm. 6. Ball lightning, a rare form of lightning in which a persistent and moving luminous white or colored sphere is seen. Ball lightning can last from a few seconds to several minutes, and it travels at a walking pace. It usually ranges in size from 4 to 8 inches, 10 to 20 centimeters. But it has been observed at sizes between 2 inches to 6 feet, 5 to 183 centimeters.
What is the snow line?
The term snow line can refer to two different things. 1. The elevation on a hill or mountainside above which snow has fallen and below which the precipitation turns to rain. Or 2. The latitude north of which is covered by snow.
What is global warming?
Global warming and the greenhouse effect are not necessarily the same thing. While the greenhouse effect can cause global warming, other things can lead to the planet warming or cooling. Other factors include changes in geography, plate tectonics, and cycles of the Earth's orbit around the Sun. It is known that global warming is necessary to a certain point, without the ability of certain gases in the Earth's atmosphere to help retain radiation from the Sun, our planet would be a cold ice ball in space. These gases act like the glass of a greenhouse, thus the name greenhouse gases, trapping much of the energy emitted from or bounced off the ground and keeping our world warm. This, in turn, allows organisms, plants, animals, and otherwise to live. More recently, global warming has been used to describe the unnatural increase in the average surface temperatures around the world. Many scientists, and others, believe humans have pumped excess amounts of greenhouse gases, such as carbon dioxide, methane, and nitrogen oxides, into the atmosphere, causing temperatures to rise. Something has already raised the surface temperatures about 0.5 degrees Celsius 1 degree Fahrenheit. In the past 100 years, and scientists believe it to be human-induced.
What causes deep ocean currents to flow around the world?
The deep ocean currents are driven by thermohaline circulation, which is movement caused by differences in the temperature and salinity content of the water. Because cold, salt-laden water is heavier than warm water, it sinks to the bottom of oceans. To replace it, warmer water fills in, and as it subsequently cools, the rotation is repeated. This constant movement of water has often been referred to as a giant global conveyor belt or pump that slowly circulates water all over the world's oceans. For example, the warm Gulf Stream current is heated by the sun, starting in the Caribbean. It then flows north along the east coast of North America, mostly along the United States coastline, until it reaches subpolar waters in the North Atlantic. Between Greenland and Norway, the cold Arctic winds cool the salt-laden water almost to the freezing point. Huge amounts of the now cold, heavy salt water sink at this point to depths of around 3 to 4 miles. 5 to 6.5 kilometers, and begin the next phase of the journey. Traveling southwards through the western Atlantic basin to the Antarctic circumpolar current, and then into the Indian and Pacific Oceans. This trip takes many years. Off the coasts of Peru and California, for instance, upwellings often consist of ocean waters that sank to the depth centuries before.
Have hailstones ever proven to be deadly?
Strong hails can be heavy and plummet at speeds that have been known to break windows, dent cars, damage roofs, destroy crops, to the tune of about $1 billion annually in the United States alone, and, yes, even kill. In July 1953, for instance, 30,000 ducks were found dead after a hailstorm in Alberta, Canada. In Montana, a July 1978 hailstorm killed about 200 sheep. In the United States, not many people have been killed as a result of hail. The last reported death was on July 30, 1979. A hailstorm in Fort Collins, Colorado, killed an infant and injured about 70 other people. Storms in other, poorer regions of the world are more common. However, because poorly built shelters collapse, killing those inside. For example, in Sichuan province, China, a fierce hailstorm injured 9,000 people and killed 100 on March 22, 1986. A month later, that same year, 92 people died in Gopalganj, Bangladesh. With some hailstones reported to weigh over 2 pounds, 3 kilograms.
Does the Sun have an atmosphere?
Yes, in a manner of speaking. Since the Sun is made primarily out of hydrogen, 73%, and helium, 25%, in a plasma state, there's no visible solid surface to distinguish a dividing line between the Sun's body and its atmosphere. The surface of the Sun is a layer called the photosphere that is about 300 miles, 480 kilometers, thick and has an average temperature of about 10,000 degrees Fahrenheit 5,500 degrees Celsius. Above that is a second layer, called the chromosphere, that is thousands of miles thick, and is somewhat cooler 7,800 degree F, 4,300 degrees Celsius. Above that is the Sun's corona, which is where temperatures kick into high gear. Temperatures in the corona average about 1.8 million degree F, 1 million degree C.
How should one prepare when the weather forecast calls for the season's first freeze?
If you own a home, there are several things to do to prepare for the onset of winter. Make sure that your furnace is in good working order and that you have clean air filters. If you have a chimney and a wood-burning fireplace, have a professional chimney sweep clear it of inflammable creosote, a fire hazard responsible for many house fires annually in the United States. Also, check the chimney outside for any birds' nests, which are also a potential fire hazard. Outside. In the yard, drain garden hoses and check the sprinklers to make sure they are clear. Frozen hoses and sprinkler systems can cause pipes to burst.